All right. This is an electronic training board that I use with my students that I've added a motherboard onto. All the other boards are the usual relay logic control boards, but there's been a disconnect between moving from relay logic to moving on to furnace control boards because they are solid state logic, not relay logic. So I'm going to walk through all of the different modes. It's a working system, and I want to walk through heating mode first. Heating mode first is the only mode I had to modify wiring wise. All the other modes, your fan on and your call for cooling, those are wired conventionally. I did not have to modify them. For heating mode, since this is a furnace control board, it's going to have that induced draft motor that's going to want to energize to close a normally open pressure switch. It's also going to have that thermal bimetal overload, that rollout switch, your flame sensor, and it's going to want to energize a gas valve. I only have a red light bulb. The modifications I had to do was I had to identify our normally closed safeties and wire nut them together. Now, in this wire nut bundle, I also have the pressure switch for sensing, for proving that our induced draft motor is running. Now, before I call for heating mode, I have to make sure that this is unplugged because that switch is a normally open switch. If I leave it plugged in, it's going to go through a 2 red light error fault code. Now, I'm going to run it in heating, and I'm going to get main power to it first. So, along with the motherboard, we have that LED light. If the LED light is not on, you don't have low voltage power, at least. It's going to take a few seconds, and then we should get that LED light. So now that I'm calling for heating, I'm waiting for the light to turn amber or red. Now that one's more amber. Anywho, then I take these 2 wires that would have gone to that pressure switch, and I close them to prove that the induced draft motor is running. Now, could I actually put an induced draft motor onto this board to show that? I could, but kind of not at the same time. I have this board available because it is broken. There you go. Here's the red light that came on. The red light came on because I have the gas valves power circuitry going to the coil on this relay too, this heating relay coil. I then, with that gas valve heating relay coil energized, it then closes the switch here that passes power to our red light bulb. Now, just like any other normal furnace control board, it's going to try igniting its gas multiple times. So this gas valve is going to go through multiple iterations of energizing, turning on that red light, de-energizing, trying again. In all of that, our indoor fan doesn't come on yet. It's doing its job. That indoor fan is going to come on, I think, usually between about the 3rd or 4th try for that gas valve. Yeah, that's how I've bypassed, and this is how I'm proving, like, yeah, no, it is calling for heat. When I have students asking, well, why isn't the light on all the way, I explain to them all the safeties that come into play with a gas burning furnace. If I could get a motherboard for, say, an electric furnace, I might have an easier time with that, replacing this board with that. But it works. So that is your heating mode. Then your other modes run conventionally. See, gas valve is trying again. It's moving that gas. No flame sensing. Your fan's coming on. Now the system is back off again, and like I said previously, normal modes operate normally. So like a fan on, turns on your indoor fan. And then cooling, which is also wired conventionally, but this thermostat has about a 5-minute time delay for cooling. So I'm just going to bypass the thermostat here just to show you that yes, when we call for cooling, it runs normally as it should. There we go. Ta-da! And then, again, normal operation for a board with a furnace control board. When we stop our call for cooling, our indoor fan is going to continue to run for a little bit. It has a time delay on it, and that's all controlled within the motherboard. All right. So yes, that's how I've modified one of these boards, one of these relay logic control boards. That's the normal board. That's the normal board with just your basic relay logic with a heat sequencer down there. And then here's the one I modified for a furnace control board.